Hi everyone, I'm Jing Wang. I'm gonna talk about my models really quick in this video. And the first step I did is to separate the two cities into San Juan and Iquitos for both training and test level. And then the next step I did is to check the hat for two cities to see what kind of variables it looks like. And from the hat, it seems like I don't need to use the week start date, so I'll remove it. The next is I'm going to deal with missing values. So to check missing value first, I made a graph to see which variables has how many percentage in the missing values. For example, for NDVI, NA has the most missing values. And I'm going to fill with the most recent previous values for the missing variables for all of that. And then I'm gonna, so here's the thing. I wanna figure out the relationship with those variables with the total cases, because I know we are required to use the time series data. And for time series data, I'll need to use the city, time, and then total cases. I wonder, what about the rest of the variables? I wanna find out the relationship to see if they are necessary to add it later for another type of model. By that, I made a correlation matrix. The darker color here means it has a higher, stronger correlation. And then for both cities, that's for San Juan and this is for Iquitos. And it seems like there are two. I just picked two actually, with the most stronger correlations. Reanalysis, mean air temperature K, reanalysis specific humidity, G per kg. One for temperature, one for humidity. And then for that, I run a linear regression with total cases, a dependent variable, and then independent variable for those two variables. And then a mixed prediction. I know linear regression model is not a good one, but I still just want to figure out the relationships. And since we didn't add the times inside, so it only has the dot for the prediction values for San Juan and for Iquitos. Okay, so next, we're gonna start the time series forecasting model. To make the forecasting model, frequency 52 weeks, and then start with 1990 and then week of 18. So next is I'm going to separate the train and test data. Since it requires us to have the test data set for San Juan for 5 years and then Iquitos for 3 years. And that's how I separate them. And then the first model I use is a RIMA model. I want to look at the ACF, PACF to find out to see if they are stationary. Oh, by the way, go back to the graph of time series. This is a San Juan, and it is the non-seasonal data set. And then there is a peak at the end of 1994. It drops at the beginning of 1995. I do check the history of that time, and it shows the real data says it really happens at that time, and it has a government report to say how they fight for the dengue disease. Okay, sorry, back to the RIMA model. And then this is non-stationary, so I want to make it stationary, so that make the first differences. And then ACF graph, PACF. So by looking at that, this is the linear exponential smoothing with damped trend, and by the order of 112 RIMA. And this is a forecasting graph. To me, it doesn't look like a good model because it's just a straight line. And then the second one is I want to check the residuals. And to me, it has white noise because the majority of the line of ACF, PACF are within the blue lines. Of course, I checked the accuracy, but I'm going to talk a bit about it later. And I'm going to just do it again for the IQ. Again, for RIMA. and then differences, and it seems like it's an MA2, and then the order is 0, 1, 2. So I'm going to use that. And this is a forecasting graph. So it just looks like a straight line, not very good to me, and check the residuals, make sure everything is okay. And then the next model I use is neural networks. I made a graph right here. So the blue lines are the forecasting I made using neural networks. And then the red lines are the actual real test data set. To me, it's not that good, but it's at least better than ARIMA. Same things again for EQUATOS. Same. This doesn't look that good because it is non-stationary. It changes a lot, but it still looks like a straight line for the forecasting. The next one I use is EDS model. I use a model for ZZZ, and then there's a decomposition graph by ETS ZZZ model. And then the forecasting for ETS in the next 5 years still looks like a very straight line, just similar to ARIMA. And then here, same. By the way, when I run the ETS model, it has a warning, says I can't handle data with frequency greater than 24, seasonality will be ignored, try STLF if you need seasonal forecast. Okay, it seems like it gives me an advice for what I need to do next. So next I'm going to use STLF. So I'm going to do the histogram first, and then see, seems like we need the Box-Cox transformation because it's not normal distribution. And then the first one I use is naive for STLF, forecasting from STL plus random walk. It looks good to me, the forecasting model. And then the second one was same, STLF, but this time was random walk with drift, and still adding the Box-Cox transformation. It looks like no difference to naive one. And then do the same thing again for EQUATOS. Looks good to me, the random walk, the naive one, and also the one with drift. And oh, that's it for the model building. But as I said, let's go back to the accuracy. I made a plot for combining all of the models, RMSE, MAE, and MASE. Let's look at MASE first for City San Juan. And then I'm kind of surprising to see that actually ARIMA model is the best one. It has the lowest MASE. But EDS, the second one, it doesn't have really much differences. For EQUATOS, that's what I'm expecting. STLF is the best model. But just back to it, looking as a whole, RMSE, MAE, MSSE, all of them, like the models doesn't have a really big differences. And so I would say they all works, but if I still have to pick one, I'll pick someone for ARIMA and then EQUATOS for STLF. And also I did submit I submit the one was to the data driven, and this is the code right here. I haven't put it into the RPUBs yet because I haven't got the score yet. I'm not sure how long it takes, but once I get it, I'll update it to the RPUBs. And thank you, everyone. That's end of my presentation. Feel free to make comments under the discussion board, and have a great night.